In this, we are going to discuss the first algorithm of the tree traversal, that is DFS. It is also called backtracking, and we will see why. The DFS can build a spanning tree for a connected simple graph. The idea is to form a rooted tree, and from it we can get a spanning tree by the following method. Select any arbitrary vertex as a root. Form a path by adding nodes and link, where every link is incident to the last vertex, connecting a vertex not in the path. Continue this process as long as possible until the path hit all the nodes. Then we will get a spanning tree. If not, move back to the next to last vertex in the path and select a new path from it and pass through all the non-visited vertices and continue the process until a spanning tree is obtained. And if not, then move back again and do the process again. In this example, we have to find out the spanning tree by using DFS. In here, we are going to select the vertex F. As a root. And what we are going to do, we are going to make a path from it. A path that is going to visit the following nodes. Now we obtain a path and we cannot add any more edge because in this graph the node J is the last node or the leaf of this graph. So what we are going to do, we have to backtrack from J to K because there are some leftover vertices left. This implies we have to backtrack it. Going one step back, now we are at the K. As you know, there is no vertex here to visit, so we have to backtrack again. Now we are at this vertex. We can make a path from here to visit the vertex I. Backtrack once, backtrack twice. Now we have made a path. Since there is no more nodes, we have to backtrack again. And in this case, we have to go back to the node F and start a new path of D, E, C, and B as follows. D to E, E to C, C to A. Now we backtrack to C and form a path to C to B. From A, you are going to backtrack again to C, and from the point C, you are going to make a new path to connect to the last vertex B. Now we have obtained a spanning tree by backtracking. We can make a simple algorithm in two parts. The first part going to have the name of DFS, the name of the algorithm. In this, we are going to give a simple connected graph as an input. And the graph is defined by the vertices V1 to Vn. In the block of statement, what you are going to do is to declare a variable t That is a tree of only one vertex, V1, because this V1 is going to be play the role of the root. Now, in the second line of the block of statement, you are going to define a function that is visit v1, and we are going to use this function in the second part of the algorithm here. In the second part of the algorithm, the name of this algorithm is visit. It will take the input v, and v is the vertex of the graph g. In the block of code, you are going to use the for loop for starting from the w vertex, that is the neighbor of the vertex v, that is not a path of the variable t. In the line of code, you are going to code a code where you have to add the vertex w to the vertex v and save it in the variable t. In the last line, you are going to call the visit again by the parameter w. I know the algorithm is not straightforward because the algorithm is in the pseudocode, and the pseudocode is only provided to simplify the idea of the real code, what the real code is going to do.